Hello class, now I want to do an exercise from our additional mathematics in dual language program from 5 DLP. I want to do summative exercise chapter 8 Kinematics of Linear Motion, summative exercise question number 14 and 15. Hello everyone, here is the summative exercise question number 4. Teacher Aziza conducted an experiment to determine the velocity of the trolley along a straight track. The velocity v centimeter per second of the trolley after passing the fixed point O is given by v equal to t square minus 7t plus 6. Assume the movement to the right is positive. Question number A. Find the initial velocity in centimeter per second of the trolley. Question number 2. The range of time in second when the trolley is moving to the left. Question number 3. The range of time in seconds when the acceleration of the trolley is positive. And then question B. Sketch the velocity time for the movement of the trolley for t between 0 to 6 seconds. Okay, we start with question number A1, the initial velocity. Okay, as you know, initial velocity. Okay, initial velocity is happen when time t equal to 0. Okay, at the starting point, or we can say here at the fixed point O. Okay, so v will be equal to t square 7t plus 6, substitute t equal to 0, will be equal to 6 centimeter per second. Question number 2. Range of time in seconds when the trolley is moving to left. Okay, what is mean by moving to left? Moving to left means in opposite direction. Okay, opposite direction of the right. When the right is positive, so to the left, the movement is in negative, or it is velocity less than 0. Okay, the formula, all the formula in this chapter you must understand and memorize. What is formula for initial velocity, and here what is formula for velocity when it is moving to the left. Okay, and then we continue. T square minus 7t plus 6 less than 0, and as usual this is a quadratic, so normally we will factorize into two brackets. Okay, tt and 6 1 minus minus, so our t will be equal to 1 second and 6 seconds. This is less than 0. We can do same what we do in quadratic equation. 1 and 6 less than, it is in between 1 to 6 seconds. Okay, this is the range of times when the trolley is moving to left, and as you know, range must be between, or having symbol more than, less than, more than or equal, or less than or equal. Alright, and then question number 3. The range of time in seconds when the acceleration of trolley is positive. Okay. Question number 3. When the acceleration positive, it is acceleration more than 0, and acceleration is dv dt. dvdt more than 0. So what is dvdt? We have to factorize function of velocity. 2t minus 7 more than 0. Here is t more than 7 over 2, or we can write as t more than 3.5 second. This is 7 over 2 second. This one is accepted. This one also accepted. Alright, question B. Okay, question B. What question B asks? Sketch the velocity time for the movement of the trolley for t between 0 and 6 seconds. Sketch the velocity time graph. Okay, sketch velocity time graph. So we take our ruler. For it is this is time axis, and then velocity axis. Okay, this is time. X-axis will be time, and y-axis will be the velocity. Okay, basically to sketch graph, we have to do when t equal to 0, v equal to what, and when v equal to 0, what is the value of t, and then the minimum or maximum value. Here is a function of v is t square minus 7t plus 6 as given in the question. So when v equal to 0, okay, this one we can take from here. When t equal to 0, it is when v equal to 0, it is time 1 and 6 seconds. Okay, when v equal to 0, time is 1 second and 6 seconds. And when t equal to 0, v will be 6 centimeter per second. And the graph is like this. We have to get the minimum value. Okay, how to get the minimum value? The turning point we learn in quadratic function, it is dv dt equal to 0. Or in chapter 2 form 4, or in chapter differentiation. Okay, in chapter differentiation, we learn dy dx equal to 0, right? So for here, it is v against t graph. We do dv dt equal to 0. So it is 2t minus 7 equal to 0. T is 3.5 second. Okay, based on here, okay, we put the scale. Okay, put the value in both axes. It is 0 here. For t, we have a t equal to 1, and then t equal to 6. Okay, the question asks us to draw between 1 to 6 seconds, right? 0 to 6 seconds. So we have to do the range from 0 until 6 seconds. And then we want to sub the value 3.5. When here is around 3.5. Okay, it is 3.5 in the middle. And then we sketch for do the scale for velocity. V equal to 6. Okay, we have V equal to 6. For example, it is here. Okay, and then one more we have to get is when t equal to 0, what is value of V? When t equal to 3.5 seconds, we have to do 3.5 square minus 7 bracket 3.5 plus 6, and then use calculator. Okay, here is 3.5 square minus 7 multiply 3.5 plus 6, it is negative 6.25. Okay, so the coordinate will be, for the minimum value, minimum value coordinate will be 3.5, negative 6.25. Okay, when t0 v equal to 6, so it is here. When v0 t equal to 1 and 6 seconds, and then when 3.5 minimum value, for example, here is a negative 6.25, and then we sketch the graph. Alright, okay, the shape is like here, like this. Sketch the velocity time for the movement of trolley 0 until 6 seconds. So we finish our solution for question number 14. Alright, here is question number 15, which is the last question in our textbook form 5. A particle moves along a straight line and passes through a fixed point O. The velocity v meter per second, t second after passing through O, is given by v equal to t square minus 60 plus 8. The particle stops instantaneously at point P and R. Assumed motion to the right is positive. Question A, find the minimum velocity in meter per second of the particle. Question B, calculate the distance in meter between the point P and R. C, sketch the velocity time graph for t between 0 and 7. Then determine the range of values of t when the velocity of the particle is increasing. Okay, question A, find the minimum velocity. We are given that velocity, velocity equation, velocity function is t square minus 60 plus 8. Okay, and then find the minimum velocity of the particle. What is the formula that is relate with minimum velocity? Okay. What is formula of minimum velocity? Okay, we have to memorize. The minimum velocity formula is acceleration equal to 0, and acceleration is equal to dv dt. Okay, dv dt equal to 0. dv dt is 2t minus 6 equal to 0, and then t we will get equal to 3 seconds. We get t equal to 3 seconds. Question asks minimum velocity. So we use again the formula of velocity, t square minus 60 plus 8. The moment of minimum velocity is happen when t equal to 3 seconds. So we substitute 3 square minus 6 bracket 3 plus 8 equal to negative 1. Negative 1 meter per second. Okay. Negative 1 meter per second is the minimum velocity. Question B. Calculate the distance in meter between point P and point R. Okay, point P and point R is where the particle stops. Okay, the particle stops instantaneously at point P and R. There are two places. Okay, two places the particle stop. Okay, position P and position R, the particle is stopped. So we use formula of velocity when the particle stop. Velocity equal to 0. So we put velocity equal to 0, t square minus 60 plus 8 equal to 0. Factorize. T for 2 then t equal to 2 and t equal to 4. The particle stop at the moment t equal to 2 seconds and 4 seconds. Okay, now we have to get the position. Okay, the position of P and R. The position of P and R happen when t equal to 2 and t equal to 4. So the position, to get the position, we have to know the function of S. S is equal to what? Integration of velocity with respect to t. Integration of t square minus 6t plus 8 dt, where it is equal to t power 3 over 3 minus 3t square plus 8 plus c. Okay, this is function of S. And we still didn't get the value of c. You have to remember that this is indefinite integral. Okay, indefinite integral which is having the value of c. So how to get value of c? We have to know when t equal to 0. Okay, when t equal to 0, what happened with value of s? When t 0, the value of s will be also equal to 0 at the starting point. At the starting point or passing O. Okay, when t0 as 0, here is 8t. Okay, c will be also equal to 0. So now our s is 1 over 3t power 3 minus 3t square plus 8t. Right? Then to get the position of P and R, we substitute when t equal to 2 and when t equal to 4 seconds. Substitute into the formula of displacement. S will be 1 over 3 2 cube minus 3 bracket 2 square plus 8 bracket 2. The answer will be equal to 1 over 3 2 cube minus 3 bracket 2 square plus 8 2. Okay, the answer is 6.667. Okay, or we can do 20 over 3 lah. Okay, because the calculator give a very long decimal, and then for value of s when t equal to 4, okay, we use the same function, just change the value of t. So here it is 4. Here it's also 4, and then 8 multiply 4. The answer is 16 over 3. Okay, 16 over 3. We put in the formula 1 over 3 4 cube minus 3 4 square plus 8 4 equal to 16 over 3. Okay, so this is the position of P and R. Okay, position of P and R. So to get the distance between P and R, it is the distance between position 20 over 3 meter and 16 over 3 meter. So we have to minus distance of P and R. Okay, it is 20 over 3 minus 16 over 3, it is 4 over 3 meter, or it is in decimal, when 4 divided by 3, it is 1.33 meter. Okay, 4.3 meter or 1.33 meter. So this is the answer for question B. Yeah? Okay, 1 over 3 or 4 over 3. Okay, here is question number C. Sketch the velocity time graph for t between 0 and 7. Then determine the range of values of t when the velocity of the particle is increasing. Okay, now we sketch the graph of velocity time graph. Okay, here is time exists, x exists. Okay, t exists. And v exists, right? Here is t and here is v, and the given value of v in the question is t square minus 6t plus 8. Alright, between t from 0 until 7, so we have to do when v equal to 0, what is value of t, and when t equal to 0, what is the value of v, and then since this is a minimum value, we have to get the minimum value of v. Okay, the first is when v equal to 0, what is value of t? It is t square minus 6t plus 8 equal to 0, that we already get just now from here. Okay, from this factorization, t equal to 2 and t equal to 4. Okay, t equal to 2 and t equal to 4. And then when t equal to 0, velocity will be equal to 8 meter per second. And minimum value of velocity we already get from question A. Okay, minimum velocity. Okay, minimum velocity is also the minimum value in a graph actually. So minimum velocity we get from A, it is negative 1 meter per second when t equal to 3 from here. T equal to 3, velocity negative 1. Okay, velocity negative 1, t equal to 3, or in coordinate it is 3 negative 1. Here is coordinate 2 0 and 4 0. Here is coordinate 0 8. Okay, so we substitute and plot this graph. Okay, this point 2 0, 4 0, 0 8 and 3 negative 1. Here is 0. Here must be 7. Okay, the range of values of t given in the question. Two, 4. So here 2 and 4. 3. T0, v equal to 8. Okay, we plot the coordinate 0, 8, 2, 0, 4, 0, 3, negative 1. For example, here is negative 1. So the plotting will be here, 3, negative 1. And alright, when t equal to 7, we have to get when t equal to 7, v will be 7 square minus 6 bracket 7 plus 8 equal to 15. Okay, the coordinate will be 7, 15. Okay, 7, 15. 15 will be around here. For example, this is 15, V, okay, coordinate V, 7, 15, okay, right here. So we connect all the points that will make a quadratic graph. Okay, quadratic graph of velocity against time. And then question asks what? Okay, now we finish the velocity time graph for t between 0 and 7. And then question asks sketch determine the range of values of t when velocity is increasing. Okay, what is happen when velocity increasing? Velocity increasing. Okay, velocity increasing is actually happen. Okay, now velocity is y-axis, right? Okay, velocity is y-axis, and you have to look the curve of graph carefully. Where is the curve that having an increasing values of y-axis, or right here increasing values of v-axis? So it is actually from this minimum values, right? Okay, the minimum value, okay, until this position. Okay, what I highlight right now, okay, is the curve of velocity time graph when the velocity increasing. Okay, it is actually continuous until more than 7 seconds. So v is increasing when t more than 3 seconds. Velocity of the particle is increasing when t is more than 3 seconds. Okay, here is answer for question that asks you determine the range of values of t. Okay, here is range of values of t. Range of values of t, when we look at the word of range, it must have a more than, less than symbol, or symbol between, or more than or equal, or less than or equal. Then right now we already get t more than 3 seconds. Okay, why don't we have answer t more than or equal to 3 seconds? Why don't we start from 3? It is actually start from more than 3, increasing. Values of velocity when t equal to 3 is minimum. Okay, it is a minimum, not increasing yet. okay, it start increase when it is more than 3. So now we finish question number 15. And until we meet again on our next class.